All right, my friends. So the next module that we are going to cover is about the fundamentals of object-oriented programming. Okay. And actually, I have told you many times. I mean, we were studying classes in the previous module, and we were studying other concepts in earlier modules, other built-in type of objects and built-in type of actions that you can perform on a Python programming environment, such as creating loops, creating functions, or importing data, importing objects from another program, so on and so forth. Okay. Uh, in all of these concepts, as I have told you, we have basically applied the philosophy of object-oriented programming. We do not actually created user-defined classes until the previous module. However, the objects on which we are working on as built-in type of objects in Python are basically objects on which you can apply methods, right? For example, we have told that for string objects, you can use the index method. For list objects, you can use the append method, so on and so forth. Okay, that means what? Actually, our programs were evolving around objects, not functions themselves. So we were creating an object, and on this object, we were applying a method. We have also done the other way around. So we have created functions and we have passed some objects as arguments to these functions, and that function has returned or printed something, okay? Or it has manipulated the data that we have passed into. However, you can do both. I mean, you can use a function-oriented program, you can develop a function-oriented program or an object-oriented program, but we need to definitely teach the object-oriented programming. Why? Because for large-scale software development, object-oriented programming approach is much more efficient than the function-oriented approach. For small-scaled programs, in order to solve, for example, a small-sized industrial engineering problem, obviously, function-oriented structure, which is basically using the whole knowledge that you know of up to this point, is much efficient. Okay, so for short-term objectives, you can use the knowledge up to this point, but for long-term programming development, you need to learn the object-oriented programming. So as industrial engineers, so not everybody in this class is an industrial engineer, but let me tell you that unless you are a computer or software engineer, obviously you are not going to be a part of a software, large-scale software development as the coder, right? So you are not actually going to write object-oriented programs. You are not going to be coders. I mean, if you do not change, if you do not have plans about career change, obviously, if you think about switching to become a software engineer or computer engineer, I totally understand you. In that case, you are definitely going to do these kind of things. You are going to develop object-oriented programs. However, as other engineers, we definitely need to understand what the capabilities of object-oriented programming. Okay, so we are learning this here not because we are going to use it in the future. We are learning this because we need to understand its capabilities. So whenever we want a computer engineer or a software engineer in the next department, okay, in the neighboring department, in the IT department, when we ask them to write a certain kind of software, we need to understand their capabilities. Okay, we should not ask them to develop impossible things, and we should not ask them to develop simple things. We should ask them to develop exactly what we want, and we also need to consider their capabilities about programming such structures. So this is why we are learning object-oriented programming, my friend, okay, to understand the capabilities of this. So as an industrial engineer or another engineer, when we need to integrate our job with the computer engineer's job, we need to understand their point of view as well. Another thing here is this: computer engineers, they know how to, or software engineers, they know how to develop good object-oriented software, definitely. But you know, today in industry, we are developing software to support our business operations, right? Business processes. For example, an ERP, we are developing an ERP software, enterprise resource planning software, or an MRP software, manufacturing, I'm sorry, materials requirement planning software. All of these softwares in industry, in business, are used to support the business processes. An MRP system is used to support the manufacturing system by efficient replenishment of the inventory, or an ERP system is supporting an organization to efficiently allocate its resources when they are needed. Okay, so you are going to learn about these management information systems. In general, we call all of these management information systems, or in short as abbreviation, MIS. And you also know that there's a separate department in our university that is called MIS, Management Information Systems. So these management information systems, we have different classes of management information systems, and we also have different versions of them to support different classes of business operations. Now, as industrial engineers, it is our role to define how these management information systems are going to support us. Okay, so if we are going to develop an MRP software as industrial engineers, it is in our it is job definition to define how this software is going to perform. Okay, what type of interface it is going to have, how it is going to interact with the user, what kind of operations it will be capable of performing. So we are going to be the analysts. We are going to be analysts of the business processes, and we are going to understand these business processes, and we are going to define how the software is going to support these business processes. Okay, we are going to be the analysts. We are going to understand the business processes. Computer engineers, however, they will not be having any background on understanding the business processes. So they are not going to have any idea about manufacturing. They are not going to have any idea about assembly lines or manufacturing cells. So as industrial engineers, we know these kind of things, but they will not. Okay, so together, computer engineers, software engineers, or industrial engineers, they built a team which is called the IT department. Okay, this team is called the IT department all together. So in IT department, industrial engineers should be working as business analysts. So they need to analyze the business processes, and they need to define the software, how the software is going to support the business processes. And the designers are going to be the computer engineers, such software. So you need to teach them how the software should support the business processes, but they are not supposed to know about anything about the business processes themselves. Okay, so because of that reason, we definitely need to understand what the computer engineers are doing, and they need to understand what we are doing, but we do not need to understand the back end of what they are doing, and they do not need to understand the back end of what we are doing. So we need to be communicating with each other. So when they speak about objects, inheritance, composition, association, and all object-oriented related terms, as industrial engineers or as other engineers nowadays, we definitely need to understand what they are speaking about. Okay, that was a very, very long motivation why object-oriented programming is important for you. Now we are going to define the object-oriented programming in a very, very short way, and we are going to mention about the pillars of object-oriented programming. So what do I mean by pillars? So as I have told you, this is the fundamentals of object-oriented programming. We are trying to create a foundation for this concept here. And over this foundation, there are certain pillars which are very important for object-oriented programming. So I'm just mentioning about some concepts related to object-oriented programming here. These concepts can be classified as polymorphism, composition, inheritance, encapsulation. I'm not going to teach all of these things to you, but they say that there are mainly four very, very important concepts about object-oriented programming that we definitely need to understand. If you really want to create an object-oriented programming, we definitely need to understand these four concepts. These four concepts are like The horses of apocalypse. Okay, if object-oriented programming is apocalypse, these are the four horses. Okay, so they are basically concepts that are helping to support object-oriented programming philosophy. And with when these four concepts interact with each other, they are creating so much efficiency in writing programs. Okay, so again, I am repeating, these four concepts are called encapsulation, polymorphism, inheritance, and composition. We are going to mention about three of them. We are not going to talk about encapsulation, my friends. Sometimes it is related to abstraction. I mean, remember, our ultimate objective in this course is to develop object-oriented programs to solve industrial engineering problems. We are not learning these things to develop software itself, but I mean, I'm not bounding you. You definitely should check different textbooks about this, or web pages about which teaches the object-oriented programming in Python, how it is developed. There are so many exercises and practices that you can learn new kind of things. I'm just going to teach you the main idea, the main pillars here. These are going to be polymorphism, composition, and inheritance. The most important one of them is inheritance, definitely. And we are going to develop an object-oriented program this time. By the way, we are going to use classes, obviously, because I have told you that in object-oriented programming, classes are our factories to create objects, and the instances that we create from the classes are the building blocks. Okay, so we are going to develop a real object-oriented program in which we will see the concept of inheritance, the concept of composition, and the concept of polymorphism, how these work in an object-oriented program. We are going to see all of this, and we are just going to mention about a new concept that is called customization. Actually, customization is helping us to develop polymorphic methods. What do I mean about polymorphic methods? You are going to understand when the time comes, but let me explain it in short. A function, a method is polymorphic when what it is going to do depends on the object on which it is going to be applied. Okay, actually, this is something I have already mentioned. I have told you that the asterisk operator does multiplication for two numeric values, but it repeats a string if you multiply a string with a numeric value. Okay, so what the operator is going to do is dependent on the object on which it is being applied. Okay, so this is called customization, my friends. Customization. So you know this terminology. You are going to learn this terminology in production planning course as well. It is not going to be related to programming, obviously, but in production program planning, they will teach you this concept, mass customization. Mass customization means what? Mass customization. What the product is going to do is basically dependent on the desires of the customer. Okay, so you know, an automobile factory can manufacture a standard automobile for everyone, right? With the same color, with the same properties, same specifications. Okay, so we can say that every automobile are going to have a automatic shift right now. Okay, from now on, so there will be no manual shifts. All automobiles are just going to be standard. Everything is going to be automobile. But this is what? This is basically a standard production, right? We have a standard production definition, a product definition, and all we are manufacturing is a standard product. Okay, then no customer will be happy about it, right? Because the customers are looking for specific attributes in their automobiles. Okay, they want to satisfy their own desires. So in order to satisfy the desires of different type of customers, we need to customize our automobiles. Okay, we need to customize our automobiles. We need to manufacture different specifications of automobiles in order to satisfy different types of customers and in order to expand our market share, obviously. So customization terminology has a meaning there as well. We say that when a product is customized, the actions that this product is going to do is defined on the customer to whom we are selling the automobile or we are selling the product itself. Okay, so here customization means this. The method, for a method, what it is going to do or what it is going to be performed will be defined on the object on which we are applying the method. Okay, this is called customization. Again, something that we have already mentioned, but we have not named yet. Okay, this is the first time that we are naming this concept. It is called customization. Okay, every once in a while I need to check my minutes. I have still time to complete this first hour. So let's speak about object-oriented programming now for the first time. It is defined as a programming paradigm based on the concept of objects which can contain data and code. Okay, so basically it is a programming, object-oriented programming is a programming paradigm. So it means what? It is not something tangible, it's a philosophy. So object-oriented programming is a philosophy. Okay, it is basically a method, an approach to write your program. Okay, it's a philosophy to develop your program. Another type of philosophy is function-oriented programming, which is what we know of so far. Okay, we were developing functions, and these functions were using other functions in them, and ultimately when we provide input to the program, it was returning us an output. Okay, this is a function-oriented programming approach. Object-oriented programming is another paradigm. Again, in it we are going to define classes. So it says it is based on the concept of objects which can contain data and code. Okay, so for all objects that we want to create, we need to write classes here. The classes will contain the data and the code themselves. The data is in the form of fields, what we call of attributes. Okay, in classes, you know, in class definitions, we say that every object that is going to be instantiated from this class will have these attributes. So this is called the data part of the code. And the code itself is defining the procedures in the form of procedures which we call methods. Okay, basically every object will have some attributes on it and will have some methods defined on which we can apply on the object itself. Every object will have some attributes and will have some methods. Now the attributes on the objects will be recorded on itself. However, the methods which will be applicable to the object will be recorded in the class definition. Okay, so every time we create an object, we cannot also stick the method definitions on it. Okay, because we can create a very large number of different objects in our program. But for all of these objects, if you want to apply their methods, these methods are going to be stored in their class definition. So whenever we want to use a method, first the program will check the object and understand the type of object we have there. And then in the class definition of this object, it will search the method and its definition. So it will apply that method on that object. Okay. Now, in object-oriented programming, the organization of the software design is around the objects themselves rather than functions and logic. Okay, so we have objects, and around objects we evolve the program itself. This is the first time that we are defining the object-oriented programming. However, we have already followed this philosophy since we have started learning Python. Remember, when we have created a range object, it had 3 attributes such as start, stop, and step. And when we did create a list object, there were several methods applicable on it, like index method, count method, or append method, or pop method. There were several methods which we can apply on the list, or dictionaries, or sets. Some of these methods were sharing a common name. For example, the index method is applicable both to strings and both to lists. Okay, some of these methods can be applied to different type of objects. Again, this is a example of customization. So we are defining a single method. However, when you apply this method on different type of objects, it returns something else. Okay, again, this is an example to customization. So all of the attributes for these objects and the methods which are going to be applicable on these objects should be defined in their class definition, as we have said, so that class is a factory that generates objects, and class is basically determining a class definition is determining the rules of generating an object or manipulating that or manipulating that object. Now, since we have already covered classes in the previous module, we have seen that the class coding provides general standards for the attributes that generated instances might have, and the type of methods and what they are going to do when they are applied on the instances that we generate from this class. Okay. Therefore, we should say that class coding is the foundation for object-oriented programming, because how the program is going to evolve around the objects are defined in the class definitions. Okay. So basically, class coding is the foundation. Okay. We know the foundation of object-oriented programming, my friends. But what are the pillars of an object-oriented code structure? So we learned that we have classes to define or generate objects from this. We can define any type of user-defined class. We can define a dog, a cat, or a feeder for a farm simulation application in mobile devices, or for a student management system in our university. We can define classes such as student, instructor, or course. There can be several of them, by the way. I mean, a classroom can also be an object, as long as we are assigning the classroom to a certain course, right? A classroom can be an object. I mean, we are mentioning about instructors. We can mention about the departments and faculties. Department can be another object, and faculty can be another object. So we need to define classes for all of them in the software, right? So there is no limitation there. For every kind of object that we can think of in the system which we are going to support, by the way. I mean, the university is the system that we are going to support by developing the software, right? So the objective of the software is what? To perform registration operations of the students to the classes. So we need to think about the type of the objects that we are going to have in the software: student, instructor, course, classroom, faculty, department, whatever. Okay. I mean, you can just imagine so many things. So this is the main part of the object-oriented programming, by the way. I mean, brainstorming part. Before designing or writing the code itself, you need to define the objects which we are going to use in the software with a very, very large team during a brainstorming session. And first, we need to design the program that we are going to write. Okay. So that's the long part of the development of an object-oriented software, my friends. Coding part is easy. Coding is what? Communicating with the computer. Everybody thinks that the coding part is hard. Actually, coding part is easy. Designing part of the software is hard. Okay. So you can also understand this when you are solving a question during the exam, right? The writing part or calculation part is the easy part. How you are going to solve the problem, thinking about that is the harder part, okay? Once you have the idea in your brain about how to solve this problem, then the rest is just operations, okay? Therefore, in object-oriented programming, first we need to start with a design, thinking about the design of the software. And when we are thinking about the design, the first thing is what type of objects we are going to have in the software and how they are going to relate with each other. So for example, how a student is going to be related to a course. So we will say that the students will register to the courses, and they are just going to either pass these courses or fail these courses. So the relationship between a course and the student is this. How a course is going to be related to the instructor. We will say that every course will have a single instructor, but a single instructor may be teaching more than one course in a single semester. Okay, we need to understand the relationship between those. Okay, like this, how the instructors are going to be related with departments. We will say that every department will have a bunch of instructors, but an instructor should only be registered to only one department. like this. We need to understand the relationships between those. Now, we have already understood the objects and how we can develop a class definition for the objects, how we can define the methods on which are going to be applicable to the objects. We have already understood that. What we need to understand the pillars of the object-oriented code structure, so which is going to make our life easier, because just by defining the classes and defining so many methods in them, it is not going to ease or burden, my friends. It is just going to make our life harder. I mean, for every type of object, you are defining a class definition, and under it, you are defining so many methods, and there is no limit to that. I mean, it can go, this kind of coding can go infinitely large. How it is going to be efficient? As long as I can think about new objects that I can interact with other objects in my program, there is no limit here, boundary here about the code that I am going to write. So the pillars of the object-oriented code structure is going to make our lives easier. We are going to learn about the composition, inheritance, and the polymorphism concepts, my friends, in this module. And we are going to define what each of these are going to do in the beginning. After defining what each of these are going to do, we are going to see it in practice, okay? We are going to work with classes again, and with these classes, we are going to interact them with each other. We are going to relate them with each other, and we are going to expand our program, which will contain multiple class definitions in it, about with the ideas of composition, inheritance, and polymorphism, and you will see how an actual software is going to work around the object-oriented programming philosophy. Now, before speaking about the composition, let us stop recording and let's give a break.